Okay, so let's get right into it. We're going to break down a building standard that is so incredibly rigorous, so effective. It's really less of a design choice and more of a fundamental shift in how we use physics to build. This is the anatomy of Passive House.
But let's just start with a really simple question. What if your home or your office, or really any building, could basically keep itself at a perfectly comfortable temperature all year round while using up to 90% less energy? That's not some futuristic fantasy. That is the core promise of this entire standard.
So, how on earth is that even possible? Well, the answer is in this really powerful idea called the fabric first paradigm. Now, instead of just relying on a massive, power-hungry furnace or air conditioner to fix a leaky, inefficient building, you engineer the building's envelope, its fabric, to be so high performance that it barely needs any active systems at all. And the results? They are absolutely staggering. We're talking a 75 to 95% drop in the energy you need for heating and cooling compared to a typical standard-built home. Now, it is so important to understand that Passive House is not just a collection of vague, green suggestions. Not at all. It is a performance-based standard that is rooted in hard science, with incredibly strict targets you have to meet. A building only gets the certification if it meets 4 non-negotiable, uncompromising limits. These metrics, they govern everything from your heating demand to the building's total energy budget, all the way down to just how airtight the structure is. And this isn't guesswork. It's measured, it's tested, and it is verified. You either hit the numbers or you don't. So, how do you actually hit those incredibly demanding targets? Well, it all comes down to 4 core physical pillars, and they all have to work together in this finely tuned system.
Okay, pillar number 1, high-performance insulation. And look, we're not talking about just a little extra pink fluff in the attic. We're talking about a massive, continuous thermal blanket that wraps the entire building. Think about walls that are 24 to 30 centimeters thick and roofs up to 40 centimeters thick, just packed with insulation. This super thick protective layer is really the first step to creating a stable indoor temperature. Now here's where it gets really clever. Pillar number 2, eliminating thermal bridges. All that amazing insulation is pretty much useless if heat can just find a shortcut to get around it. A thermal bridge is like that shortcut. Imagine punching a metal nail right through the wall of a high-end thermos. That nail becomes a superhighway for heat to escape, right? Well, Passive House design meticulously hunts down and eliminates every single one of those weak points.
Pillar 3 is all about extreme airtightness. This means creating a continuous, unbroken air barrier that wraps the entire building, like a perfect seal. And that seal is so tight it has to be proven with a special machine called a blower door, making sure you have less than 0.6 air changes per hour. Now, this stops all the drafts, yeah, but what's really crucial is that it also stops moisture from getting into your walls, which makes the building unbelievably durable. I mean, they've studied 25-year-old certified homes, and these seals are still perfectly intact. Okay, so if the building is a perfectly sealed box, how do you breathe? That brings us to pillar number 4, heat recovery ventilation, or an HRV. This is basically the building's set of mechanical lungs. It's constantly pulling stale, moist air out and bringing fresh, filtered air in. But here's the magic trick. As the 2 air streams pass each other inside the HRV, over 75% of the heat from the warm air going out is transferred to the cool, fresh air coming in. So you get all the fresh air you need, but for free, thermally speaking. Now, this next point is absolutely critical to understand. These 4 pillars, they don't work in isolation. Not at all. They create what's called a closed-loop synergy. You absolutely cannot pick and choose these things like from a menu. You can't say, oh, I'll take the super insulation, but skip the airtightness. It doesn't work that way. It is a complete interdependent system. And this image here shows it perfectly. The 4 pillars have to lock together, just like puzzle pieces. You take away even one of those pieces, and the whole system, the whole high-performance picture, it just falls apart. So here's how the equation actually works. Step 1, you take that ultra insulation and you get rid of the thermal bridges. And what you get is a thermally stable box. Step 2, you add extreme airtightness to that stable box, and now you've got a sealed box that traps heat. But a sealed box also traps stale air, and that's where the HRV becomes mandatory. It's the lung that makes the whole box livable, turning it into this high-performance, living, breathing organism. Of course, the big question on everyone's mind is always about the cost. So let's take a look at the economic balance sheet and see how that upfront investment actually pays off over time. And yes, let's be upfront about it. There is a construction premium. It's typically about 5 to 10% more in markets where this is common. But as you can see on this scale, that initial extra cost is absolutely dwarfed by the massive returns you get over the life of the building. Let's start with the most obvious one, the savings. A typical passive house sees a 78% reduction in its annual heating costs. Just think about that. That is a huge, immediate return year after year after year. But the savings, they go way beyond just your energy bills. And this is where it gets really interesting. In commercial buildings, the amazing air quality and the super stable, comfortable temperature have actually been measured to boost staff productivity by nearly 11%. Now that's a return focused on people, and it can be even more valuable than the energy savings. And when you combine those operational savings with these huge gains in human productivity, the payback period for that initial investment, it can shrink to as little as 7 years. After that, it's just pure profit, pure savings. But the real power of this blueprint, the real genius, is its infinite scalability. This is not just for single-family homes in Germany. This is a truly global solution. And this isn't just a theory. I mean, look at this range of real-world examples. You've got the world's tallest certified passive house, a high-rise tower in Spain. You've got the world's largest development, an entire city in China built to this standard, an office building in Melbourne that cut its electricity use by 85%. And get this, even an educational campus in the extreme desert heat of India that uses these exact same principles for passive cooling. And that right there proves the most important takeaway. Passive house is not an architectural style. It's not about making every building look like some futuristic box. It is a flexible, invisible engine of performance that can be put inside any building type, in any climate, at any scale. So in the end, the physics behind it all are actually pretty simple, but their application is nothing short of revolutionary. High-performance insulation, no thermal bridges, ultimate airtightness, and continuous heat recovery. It's the physics of the future, being built right now, today, a real, tangible blueprint for a more comfortable, more resilient, and radically efficient world.